Hello guys, welcome to our class. This is going to be a very brief lecture, and we are going to discuss power transmission, right? So we just discussed transformer, so I feel like we should just have a basic understanding of how power is transmitted from generation station. Then we'll just look at the induction coil so that we can wrap up this aspect of physics class. Okay, so please get your writing materials ready so that we can go straight to our class. This is Normal Science Tutors Online, and we are your online physics tutors. I remain notable Michael. Please, if you have not subscribed to this channel, please, what are you waiting for? Please subscribe to the channel, give us a like, give us a thumbs up, and give us a positive comment, and invite your friends to come and enjoy what you are enjoying in YouTube. This is a complete curriculum of physics. That okay? If you check our channel, you find that we've uploaded a lot of videos. We've uploaded over 100 videos on different topics. We've broken them down into small segments so that you can understand it, and then we just tailored it towards the wired curriculum of physics. So you have the part that is for SS1, the part for SS2, and then the part for SS3. So you can pick any of the lectures that suits you, view them, solve the problems that are applicable, and then combine it with your text, and then you finally become a better you in physics. Okay, so please get your writing materials ready so that we can go to power transmission for this class, right? So let's go. So generally, when you are at home, if you don't have lights, like in our country, Nigeria, most of the time power is always a problem, and the reason mostly is that Nigeria is not generating enough power as it should be. So, but when power is generated, definitely it has to be transmitted to the consumers. So, how is this done? Okay, so power generated at power stations, they are distributed over long distances to consumers through metal cables. So, if you drive around the city, you will see cables, right? You see electrical cables. So power can be transmitted either at low current and high voltage, or at high current or low voltage, as the case may be. So you can have power either at low current and high voltage, or at high current and then low voltage. Alright, so when power is generated and transmitted, there is heat loss, or there is energy loss in the form of heat, right? So when power is transmitted, there is energy loss. Why? Because of the resistance of the cables that are used to transmit the power. So energy is lost in the form of heat, and most of this energy that is lost is as a result of resistance. Okay, so it's a result of resistance. Now, to avoid this energy loss, power is transmitted at high voltage and low current. Okay, so power is transmitted at high voltage and low current. This is a jam question. I've told myself that any information that I see in any question and I treat that topic, I will just highlight it. So this is just jam question. Know how power is transmitted from the generation station: high voltage, low current. Is that okay? Why? When power is transmitted at low current, the heat energy loss is reduced. Energy loss is what is reduced, and this power transmission is known as high tension. So if you are asked what is high tension transmission, high tension transmission means high voltage, low current. So the low current leads to low energy loss in the form of heat, right? So that's what I've stated here now. All right, so in most cases this high energy is transmitted. All right, so a step-up transformer is used to step up the voltage from the power generation station, while a step-down transformer is used to step down the voltage before distribution to customers. So most of the transformers you see close to your home, they are step-down transformers. You only see step-up transformers in power generation stations, but when it is coming to your home, it becomes a step-down transformer. So energy can be generated at a very high voltage and low current. Like maybe you say you have a 33 kVA, 11 kVA, but by the time it comes to you, the voltage has dropped to what you need, and what you need at home is 220 volts. You only need 220 volts, so you need a step down transformer to bring 11 kVA to 220 volts. All right, so that is the energy that you enjoy at your home. So this is how power is transmitted to you at your home, right? So this information is very key, and you need to understand it as a physics student. In fact, you cannot be a novice in your environment when you're a physics student. Okay, so this has to do with transmission. Now there's a small instrument that is very, very key in a vehicle, and that is the ignition coil. Right, the ignition coil actually is used to produce spark. You know what we call a spark plug now. A spark plug, if you have operated a generator before, when you turn the wheel, you see that the plug will start to spark, right? So that's a spark plug, and that is an ignition coil, right? So let's just discuss briefly what the ignition coil is and how it functions. Okay, so the ignition coil. The ignition coil is an electrical device that is capable of producing a very high intermittent EMF by electromagnetic induction from a low voltage DC source or battery. Okay, so that is an ignition coil, and then this is just a brief drawing of it. The structure of the ignition coil is that it has two coils. There are two coils. One is a smaller coil of low turn, then you have a secondary coil of more turns. So you have a primary coil made up of few turns of insulated thick copper wire wound on a laminated soft iron core. The lamination is to reduce heat loss due to eddy current. Always remember that. Okay. Then the secondary coil overlap the primary coil. Then you have a make and break system. This is the make and break system. Okay, so this is a iron hammer that when this iron core is magnetized, it attracts this, because this is a spring. It attracts, and then there's a make contact. Then once it is magnetized and the attraction is open, the magnetisms disappear and all that. Okay, so this is a battery which provides the current that is needed. Then you also have a capacitor. So all these parts of the ignition coil have their different function, or the induction coil. All right, so this is the structure, and what is the working principle? All right, so the working principle is that when the key of the ignition coil is closed, current will flow through the primary coil, and the core that is inside the primary coil is magnetized. So the soft iron armature that is attached is attracted, so that the platinum contact and the circuit is broken. So that the platinum contacts and then the circuit is broken. Alright, so at this point the coil loses magnetism and the armature is pulled back by the spring so that the contact can be re-established. Okay, so that is the armature I showed you in that picture, and then that's the major thing is that once as a make and break contact is made repeatedly, a spark is produced. Because I said before, the ignition coil is used to produce spark. So a spark is produced because of an induced EMF in the secondary coil. Alright? Because of the induced EMF in the secondary coil. Now, what are the uses? Mainly, this is where this is the most important part. It is used in car ignition system. It is used in operation of S-ray tube and MOS radio transmitter. Now, the capacitor that is in it is used to control the spark that is produced, and it is used to promote rapid decay of magnetic flux at the break of primary circuits. Okay, so these are the uses of the ignition coil or the induction coil, and the basic working principle. Alright guys, I think this one is a very short topic, and I really do not want to bore you or waste your time. Right, so this is where we stop in this particular topic. So please, if you have not subscribed to our channel, please subscribe to our channel, give us a like, give us a thumbs up, as we continue to dish out quality videos to you. Please reach out to the WhatsApp number that's showing on your screen, and then invite your friends. Thank you, and see you in our next class.